Hello everyone. Welcome back to my live stream. So we did solve the Meta or Facebook specific problems for the last couple of live streams, which I did yesterday and today. So I wanted to start with another company rather than keep digging into a single company specific problems. I think we solved around 30 problems for Facebook or Meta related interviews. Now we are moving on to Apple. So there would be a lot of overlaps. I'm expecting a lot of overlap between them. And also for the Apple, as far as I know, the process is very much team specific. So they might not have the company-wide favorite problems that they ask frequently. But still, I'm going through this list mainly because the difficulty level and the concept would be similar. Even though they don't ask the same problem, it will be almost similar difficulty level and also following the same concepts. They would be asking the problems. That's what my assumption is. And yeah, here in the LeetCode, I have followed the same strategy. I have been like first I'm thinking of the solving the problems that occurred most frequently in the past 30 days. There are 12 problems in that, and then if we filter it for 3 months, past 3 months, there are 37 problems. And then, okay, I'll prioritize that later. But in the beginning, I'll try to solve the problem of last 30 days or most frequently occurred problems in last 30 days. And then I'll move on to the 3 months in the next session. And then I'll try to uh, run down those problems or the concepts as fast as possible and finish it. So let's move on. Without any further delay, let's start with the first problem. uh, and feel free to ask me any questions that you have whenever during the live stream. I will make sure to address it. Let me open the live chat as well. If anybody joins in, feel free to say hi, and also let me know how it is going for you. Feel free to provide me any feedback that you have about these sessions and how can we make it more useful or um, make it more beneficial for everybody who's watching here and as well as for me. I know that it's definitely beneficial for me because I'm learning new concepts and I'm able to focus much more than if I was doing it alone. So yeah, great. So let's get started. So okay, the first problem is LeetCode 139 word break. Given a string S and the dictionary of strings word dict, return true if S can be segmented into a space-separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. So a single word is given, S is LeetCode, and then the word dictionary is given where they have provided the valid words. Leet and code are valid words. And we need to return true only if S can be segmented into space separated sequence of one or more dictionary words only. Okay, for lead code, we can clearly separate it as segments of lead and code, which both of which are present in the dictionary. That's why we can return it as true. And then for the next problem, if we see, there is apple. Clearly, apple is in the dictionary, and then pen is also in the dictionary, and then again apple, that is also in the dictionary. Um, so so we end up returning it as true. Return true because apple can be this word can be segmented as apple, pen, and apple. Note that you are allowed to reuse a dictionary word. Okay, and then let's look at the next example. Cats and dogs. So here, cats is in the dictionary and is in the dictionary, and OG is not in the dictionary, so we cannot segment it that way. Let's try out some other way. Cat, single cat, okay, that is in the dictionary. And then S is not in the dictionary, but sand is in the dictionary. If we take sand is in the dictionary, again we will be left with OG, that is not available in the dictionary. So so we end up returning false in this case. So yeah, so we are returning false here. So how to go about it? Let's see. So we have done this problem or solved this problem before. So what we can do is, as we are seeing in the approach of the code here, so false result indexes. So false result indexes are like, okay, um, okay, I think this is not a right approach just to look into the code, because usually what happens is we start from the most intuitive approach, and then we progress towards having an optimal approach. That's the natural way of making progression in while coding anything. So in this case, we follow backtracking approach, and then we code up a workable solution, and then we use something like a memoization in order to make it more optimal. So in that use case, let's ignore this false result indexes for now. Let's focus on this word set. Word set is a set. So if we have it in the list, the dictionary words in the list, then it's hard to look up if the word is present in the dictionary or not. So we will add it to a set and convert it as word set, and then we are adding all the words in the word dictionary into word set. And then once we have it in the set, we are making a call to the word break recursive, and then 0 is the index, and then s is the total string that is being passed, and then word set is the set of the words. And then if index is equal to s dot length, if index reaches the end of the word, then we can return true if it exactly reaches the end of the word. And then if, okay, again, this one we can just choose to ignore as of now. If for integer index, integer I is equal to index I less than s dot length I plus plus, if word dot set contains words word set dot contains s dot substring of index comma I plus 1. Okay, if word set contains s dot substring of index to I plus 1, then if word break recursive I plus 1 to the end of the string, then return true. So what we need to do here is we need to check until the end of the string if every word is contained in the dictionary. Here the base case I'm checking is if the index is equal to s dot length. That means, like, if I'm calling this word break recursive starting from the index, means that means we already got the word break until index minus 1. That's why we are making a call starting from index. That's why I'm returning it as true. If not, let's ignore this one for now. Okay, I'm just ignoring all this for now. It should work without it. Okay, you see it works without this false result indexes as well. Okay, so here what I'm doing here, let's look into this one in little bit more deeply. If word set dot contains s dot substring, like if I'm iterating through every single indexes or every single possible combinations of the word starting from the index I. So I'm starting from index 0. Let's say take an example of this word LeetCode. So I'm starting from index 0 here. I is equal to index, and then from 0 to 1. So 0 to 1, if word set dot contains s dot substring of 0 to 1 means just L. I'm just checking if the dictionary contains L. Then I'm trying to do the recursive call to eat code, EETCOODE, and then see if that returns true. If that returns true, I'm returning true. But if L itself is not contained in the dictionary, I'm not gonna do anything. I'm just adding the next letter there. So I would be incremented by one more. So now I'll compare if LE is contained in the dictionary. Even that is not contained in the dictionary. LEE, I'm checking for LEE. That is not contained in the dictionary. I'm checking for LEET. So now LEET is contained in the dictionary. So what I'll do is, again I'm checking, I'm making a call to this recursive function. If word break recursive, I plus 1, I plus 1 means after LEET, this one, code. Like this code, like I plus 1 is 0, 1, 2, 3, 4. Okay, that is 4. I'm passing 4 here, and then the word I'm passing it as entire thing. So I'm checking from the fourth word if this word break recursive works, and then I'm passing the same thing. If that returns true, then I'm returning true for this one. If that returns false, I'm not returning false. If that returns true, then I'm returning true. But if that returns false, then I keep adding it to this one. Like I just gave to LEET, and then I'll check for LEETC and then LEETCO, like that. If it returned true for code itself, then I can break it as leet and code. So for code also it returned true in this case. That's why I'm just returning for the entire thing. In this case, for example, let's come to in Apple pen Apple also the same way it will work. So I'll check until Apple is contained in the dictionary, and then I'm checking if the rest of the recursive call works for this one, and then I'll check for P, and then I'll check for PE and for pen is contained in the dictionary, and then it will make a recursive call to check if the rest of the word is can be broken, and then I'll again go character by character until I go to Apple. Okay, now Apple is contained in the dictionary. Now I'll make a recursive call with word.length, and then index will become s.length, then that would return true, and then each recursive call will return true to its parent, and then completely I'll return true here. So if that did not happen, then I would have returned false, but in this case I'll return true. Let's come to the next example, which is a false case. Here, look at it carefully. So here in the index 0, and the index was 0, I'm seeing if C is contained in the dictionary, no. If CA is contained in the dictionary, no. If CAT is contained in the dictionary, yes. Now what I'll do is, if the CAT is contained in the dictionary, now I will make a word break recursive call to check if sandog can be, or SANDOG can be broken into this one word break recursive. So in that process, I'll check if S is in the dictionary, no. A is in the dictionary, so that is made here. If that returns true, we can return true. If that S is in the dictionary, no. A is in the dictionary, no. N is in the dictionary, SAN is in the dictionary, no. Sand is in the dictionary, yes it does. So sand is in the dictionary. Now I need to check if OG is in the dictionary and in the rest of the string. O is in the dictionary, no. G is in the dictionary, no. Now the index, like I haven't come to here, so I am just checking here only. So my I value is greater than s dot length now. So this condition fails, and then I'll come out of this loop, and then I'll just return it as false. Once I return it as false, OG is not in the dictionary. So this sandog part also returns false. So the sandog also can't be broken into the format that is expected. Now sandog also returns false. What I'll do, I won't return this cat also as false, because if this is not true, I'm not returning false. What I'll do, I'll increment the I by one more. So now cat is over. I'll check for cats. For like I'm checking if the cats is in the dictionary. Yes. Now I'll follow the same approach for the remaining string. I'll check A is in the dictionary, no. AN is in the dictionary, no. And is in the dictionary, yes. So and is in the dictionary, and I returned like I need to make a recursive call again for the rest of remaining of the string. For this remaining of the string, actually, if you observe, I had already made a recursive call to check that, okay, OG cannot be broken down in the format that is expected. That is where this optimization is coming in. So false result indexes. So whenever I'm making a call with any particular indexes, so here string is constant, birth set is constant. Only varying thing is this indexes. Whenever I'm making a call for a particular index, so for example, this OG is like index 0, 1, 2, 3, 4, 5, 6, 7th index. Whenever I'm making a call from 7th index, if that is in the, that follows the constraint, it is returning false. It had returned false in the other time as well, whenever I checked for cat, sand and OG. Now I'm checking for cats and OG. So I could, like here what I'm doing is I'm computing again for OG and seeing that okay it returns false and then returning false. But instead of that, if I had I stored it in the indexes, these are the false result indexes. So false result indexes, and I'm adding it here. Since none of this returned true, I'm just adding OG or 7 as the false returned indexes. And then here I'm checking if the false returned indexes contains the current index. I'm just returning false rather than trying the headache of recomputing it or anything. So that would make it much more faster. What if I don't do this? Then it will work for the basic cases here. You can see it satisfies the basic cases, and it would fail for one of the longer input. It will give a time limit exceeded or something. Yeah, you can see AAA. So this will have a lot of combinations until B. So yeah, for these kind of cases, basically it is better if we have an optimized approach. So word dictionary doesn't contain any B's. Here there is a B. So whatever the combination that we check here, it fails to satisfy this B because B is not contained in any of the words in the dictionary. But in order to see that, we would have computed so many combinations, and so many, like you can see how it is broken down into. So there would be thousands of combinations or computations, and then I'm giving time limit exceeded. So if I had I stored the false indexes here, then I can just build on top of that rather than trying to um, just compute again every time. Let's see, run this one. Okay, so you can see this is the case here. So even for that case, it worked. And if I submit it, it works. Okay, so that's about it. Let me know if anybody has any questions. Okay, moving on. Rotate array. So here, LeetCode number 189. So it's a LeetCode medium problem. Given an integer array nums, rotate the array to the right by k steps, where k is non-negative. Rotate the array to the right by k steps where k is non-negative. Okay, 1 2 3 4 5 6 7 and k is equal to 3. I need to rotate it by 3 steps to the right. So 5 6 7 would come to this one, and then 1 2 3 4. Okay, rotate 1 step towards right. Okay, 2 steps towards right and 3 steps towards right. So instead of this one, like the best approach that we can follow here is okay, there are multiple approaches that are being followed. Let's see. What is this one? Using graph-like traversal. So if nums.length is less than 2, I mean if there is only one element, then how many times ever you rotate it, it would be the same thing. So I'm just returning it. Otherwise, k is equal to k mod nums.length. K is equal to k mod nums.length. Okay, k value, changing the k value. Int rotated count is equal to 0. For int I is equal to 0, rotated count is less than nums.length I plus plus if int current index is equal to I. Okay, in previous value is equal to nums of current value, current index. Okay, and then int rotated index is equal to current index plus k mod nums.length. Okay, this is too cluttery or too cumbersome to follow for me. At least I don't want to break my head so much. Let's see some other approach. Not because it is difficult. I don't think it's the best way to solve that problem as well. That's why I'm moving away. Otherwise, I would have tried to learn it at least. So let's see, using a reverse method. So here, if nums.length is less than 2, then I'm returning same base case, and then k is equal to k mod nums.length. Okay, and then reverse nums comma 0 to nums.length minus 1. So reverse the total thing, and then reverse nums of 0 to k minus 1 and then k to nums.length 1. Okay, I think I knew this method. So what's happening here is let's consider this one. Okay, k is equal to 3. What they are doing step by step, I'll just explain it here. This is original nums. Okay, and then first step is I'm rotating this or reversing this nums. So when I reverse it, it would become like, let me say, 7 7 6 5 4 3 2 1. So this is the first reverse, and then k is equal to k is equal to 3. Okay, so k is equal to 3. What we are doing here is reversing from 0 to k minus 1. 0 to k minus 1. K is equal to 3. 0 to 2. 0 1 2. So 0 1 2. I'm just reversing those three. So 7 6 5 becomes 5 6 7. 5 6 7. And then reversing from k to nums dot length minus 1. K to nums dot length minus 1. So 4 3 2 1 becomes, so 4 3 2 1 becomes, so that is in the next step. Let's do that in the next step. Okay, so here this one, reversing from k to nums dot length plus length minus 1, that is 4 3 2 1 would become 1 2 3 4. Okay, and then we can see that 1 2 3 4 5 6 7 rotated by three places, are rotated by k places. So how does this work, the intuition behind this approach? So we have the entire array and we just reverse it. Once we reverse it, we need to know that, okay, if we double reverse it, if we again reverse it, it would reset to the original array. But instead of again reversing the entire array, what we will do is we will separately reverse the elements before k elements and then separately reverse the elements after k elements. So that would give us a notion of rotation. Even though we are not rotating, we are actually reversing. That would make it like rotation, because like once I have this one as, okay, now it is like sorted in the descending order. Once it is sorted in the descending order until k, I will again sort it in the ascending order, 5 6 7, and then until this one separately I'll sort it in the ascending order, 1 2 3 4. So I just didn't sort them together, so that would be giving the notion or the impression of the rotation. So 1 2 3 4 5 6 7 it will be, so that would have rotated in k, because we are splitting it, like splitting the reverses at the index k minus 0 to k minus 1 and k to a length of n. So this is one of the best solution as far as I think, in terms of intuition and also in terms of runtime. So let's see. Okay, what all other approaches are there? So here, let's see what is this approach. Okay, and I didn't explain the reverse method. Reverse method is basically, while start is less than end, I'm passing the start index to reverse and end index to reverse and the nums. While start is less than end, I just keep swapping the elements across. Yeah, and start plus plus, end minus minus. And then using the additional space here, rotated array would become equal to new int of nums dot length. Okay, and then for int I is equal to 0, I less than nums dot length I plus plus, rotated array of I plus k mod nums dot length is equal to nums of I. Okay, okay, what they are doing here is I plus k nums dot length, I plus k mod nums dot length. What does that mean? Like I is 0 and then I plus k is 3, 0 plus 3 mod nums dot length is 3. So 0th basically whatever is in the 0th index is going to the 3rd index. So that means I'm already rotating it by k steps or k turns, and then I'm not rotating it in place. I'm just using additional space here. If I had rotated in space, I would have lost the value there. So I moved it as many additional spaces. Once I moved it as many additional spaces um, using an auxiliary data structure here, what I'm doing is I'm copying that values to the original number array. So that's what since I have a void return type. So that should do it, and this looks very optimal as well, but I'm using additional space here. Okay, that that does, like, these two approaches are at least intuitive to me, and they are efficient as well. So let's go with the next problem. Okay, first unique character in a string. This is a LeetCode 387, first unique character in a string, and this is a LeetCode easy problem. Given a string S, find the first non-repeating character in it and return its index. If it does not exist, return -1. So for example, for LeetCode, L is the unique character. But how do we know if it's an unique character? We can use auxiliary space, like if does not exist. Okay, they haven't asked us to use any additional space or anything. So what I'll do is I'll just create a set of characters, and I'll have the first pass to see. Okay, in the first pass, what I'll do is I'll go through each of those and add it to this, add the frequency, maybe map character, integer, char frequencies. We put a new hash map, and then I will iterate through the string. Okay, I'm iterating through the string, and then I'll have to add it to that map, char frequencies dot put c comma okay, here it should be get or default. And then once I have that, I will loop through it again, and then I'll check if char frequency start get c. If that returns 1, I mean that's a unique character, then just return. Okay, so what I'll do is I'll make an index based loop. Int I is equal to 0, I less than f dot length, I plus plus, and if char frequencies contains s dot char at I, then return I. Otherwise, return -1 if none of them are unique. Okay, let's see if there are any better approaches or optimal approaches. Linear time solution. ARC is a linear time solution as well, and they have used the same way, hash map of character and integer and count. build hash map character and how often it appears, and then find the index. Okay, it's exactly the same thing. So we don't have to do anything else. Let's move on to the next problem. Okay, valid Sudoku. So determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1 to 9 without repetition. Each column must contain the digit 1 to 9 without repetition. Each of the 9 3x3 sub boxes of the grid must contain the digits 1 to 9 without repetition. A Sudoku board partially filled could be valid but is not necessarily solvable. Only the filled cells need to be validated according to the mentioned rules. Okay, so here, like what they are telling is, okay, all the numbers in this row, in any single row, should be unique. There shouldn't be any repetition. Like in this row 5 3 7, if there was another 5 or 3 or 7, that would not be a valid Sudoku board. And here also these should be unique and these should be unique. In every row it should be unique values. And then in the same way, in every column there shouldn't be any repetition. 5 6 7 4 8 3 9 6 8 1 8 4. So all are unique here. And at the same time, in every boxes, like you can see this bold lines here, like the with which the Sudoku board is divided into 9 equal parts. Like this is one part, this is one part, and this one is one part. So in that 9 equal part, each of like the elements should be unique. So what I can do is we can create create as many hash maps. Like there are 9 columns, there are 9 rows, and also there are nine boxes. And then we have to make sure that it has only unique values in those things. So what we can do is okay, we need 9 sets in basically. We can just create 9 sets or 9 hash sets. How to create 9 hash sets exactly? So set of integer, or 9 set of integer. So it can be like row sets is equal to new int of 9. Let's see if that works. Okay, and then here it can be like column sets, and that would be right one. Okay, and then this can be like box sets, and yeah, that would be integer of 9. New integer of, not new integer actually, new set of integer. So now let's see. Let's iterate through the Sudoku board for int I is equal to 0, I less than board dot length I plus plus, and then for int j is equal to 0, j less than board dot length and j plus plus. So now in this case, all I need to do is I need to get the row of I dot. Okay, I need to check if, okay, I will just check int current is equal to board of I comma j. So that's the current value. Now I need to check in all those three boxes, uh, row sets of I dot contains, if that contains current value, if that already contains current value, then return false, else add it to that row sets of I dot add current. Same way we need to do for the other two ones as well. So other two ones are column set and box set. So column sets, if column sets of I contains current, column sets of j contains current, then return false, otherwise column sets of j dot add current. Okay, and then if box sets of, I think how to determine if it's the first one or the second one. So this would be determined by, okay, there might be a some mathematics involved. So for all these boxes, this is 0 0, this is 0 1 0 2, and then 1 0 1 1 1 2 2 2 2 1 2 0. Okay, so that means x will be less than x by 3 and y will be less than x by 3 both. So maximum value here is 2 2, 2 cross 2 4. So that means if so, how to determine that? Okay, I think I saw the solution here. The mathematical value will be I star I by 3 star 3. Box index will be plus j by 3. So I divided by 3 multiplied by 3. So I divided by 3 okay, so in box index is equal to I divided by 3 multiplied by 3 plus j divided by 3. If box sets of box index that contains current, then return false, otherwise just add it to that one. And then at the end, if we did not return false anywhere, that means it's a valid Sudoku. We can just return it as true. Okay, so it's not new. how to get this one, and this one will be O of n cross n. So and also it is character type board, so we should make it a char instead of this one, instead of integer. And then the next point is, okay, so this should be a hash set. Okay, that works. Let's not provide any type here. And current is a char. Okay, so the rest of the, other than these boxes which has digit characters, the rest of the ones have dot characters. So what we can do is, if it's not a digit, then I'll just continue. So if character dot is digit current, so if it's not a digit, return not return continue, just continue the next element. Okay, null pointer exception in here. Okay, let's take this one, this box index somewhere. I by 3 char 3, I divided by 3 char 3 plus j divided by 3. And then let's combine these false conditions once. If this contains num, if row of I contains num, or column sets of j contains the num, I mean the current or the box set of box index currents the contains the current character, then returns false. Okay, and then if that's not the case, then we need to add it to that row set. We need to add it to that column set as well, and then we need to add it to that box set also. So that's the mistake there. We need to add it to the box set, not the row set. Okay, this should be box set of box sets of box index. Okay, if row sets of I contains current or column sets of J contains current or box sets of box index, okay, first thing is I haven't initialized these sets, so I need to initialize these sets first. For int I is equal to 0, I less than 9, I plus plus. So row sets of I is equal to new hash set. Okay, and then the same thing for column sets and same thing for box sets. So I have initialized the hash set for all three. So that should not give any null pointer exception now. So I was just trying to see if it contains without initializing the set here. So row sets of I was null before I initialized it here. So now I am initialized it. I have just defined the type here, but I haven't actually initialized and added a set into that value. So now I submitted it, so it looks good. So this is the box index. Box index is I divided by 3 multiplied by 3 plus j divided by 3. What does that mean? Why can't it be I plus j divided by 3? Like if it is like I divided by 3 multiplied by 3, and this 3 anyway gets cancelled, right? So why can't it be just I plus j divided by 3? Will it work? No. So what's the catch there? I divided by 3 star multiplied by 3. Okay, it's kind of integer division. Is that the deal here? Let's check what's the significance of that box index to be exactly. For how to identify the box number for position ij, box index is I divided by 3 star 3 plus j divided by. Dividing I and j by 3 tells us which 3 cross 3 box it belongs to, since there are 9 boxes indexed 0 to 8. Okay, dividing I and j by 3 belongs to which 3 cross 3 boxes it belongs to. Okay. So let's see. we had done this way, would it make any difference? Okay, this works too. So what's happening here is I divided by 3 and j divided by 3. So here in the description, so I is the row number, so that would give the row group. Basically, these three rows belongs to row group 0, and these 3 rows belongs to row group 1, and these 3 rows belongs to row group 2. And then here for columns, these 3 columns belong to column group 0, and these 3 columns belong to column group 1, and these 3 columns belongs to column group 2. So the combination of 0 1, row group 0, column group 0, this one is row group 0, column group 0, and this is row group 0, column group 1, row group 0, column group 2, row group 1, column group row group 0, sorry, row group 1, column group 0, row group 1, column group 1, row group 1, column group 2 here. Yeah, so in order to convert that to value 9, what we are doing is we are multiplying either a row group or a column group by 3. So that would give a maximum value of 9. Let's say if one of them is 3, like here, row group is 2, column group is 2. So 2 cross 3, 6, 6 plus 2, it will be 8. 8 is the maximum number. And minimum number is, here row group is 0, column group is 0. So 0 cross 0 by 3 cross 3, it will be 0, 0 plus 3, it will be 0. So this will be 0th box, this will be first box. How? Row group is 0 and column group is 1. So 0 by 3 is 0 and 1 by 3 cross 3. So that will be 1. So this will be in the first box basically. And it if I make it as like instead of this one here, instead of multiplying it to the column group, if I multiply it to the row group, let's say, even then, let's say if I multiply it to the row group was 0, right? I was 0, 0 by 3, 0, 0 star 3, 0, column group was 1, plus 1 divided by 3. 1 divided by 3 is 0, 0 plus 0, 0. Let's see. So I was, which is row group, I was row group, so 0, 0 divided by 3, star 3, 0 divided by 3 star 3, 0 divided by anything is 0. Okay, plus j divided by 3. J is the column number. And then column numbers for these groups in these group are like 3, 4, 5. So 3, 4, 5, anything divided by 3 is 1. So that would belong to first box basically. So yeah, either way it will be 1, whatever the indexes that comes here. So that works. Okay, so we are done with the valid Sudoku. Let's move on to the next problem after a quick break. Okay, let's keep going now. We are done with the valid Sudoku. So that problem is done. Let's move to group anagrams. So this is LeetCode 49 and a LeetCode medium problem. Given an array of strings strs, group the anagrams together. You can return the answer in any order. Okay, strings are given as eat, tea, tan. Group the anagrams together. Anagrams means, I think, An anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. Okay. Okay. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. Got it. So eat and tea are anagrams. TEA. It uses up all the letters of tea and eat. And then eight also is an anagram. So eat, eight, tea are anagrams. Tan and nat are anagrams. Bat is single character. So what we can do is here with each character or each string, we can arrange the characters in a sorted order. Or yeah, we can sort the characters within a string and then check. Okay, so here I have a string to list of string. String will be the sorted order and the list of string will be all the original strings in that list. So grouped anagrams hash map. I have created a map to arrange that way. Like for example, bat as ABT as the sorted order. Like for example, I would have a map. My map would be arranged this way. If we see here, grouped anagrams will be something like this. Here, key will be AET, that would be the key, and value will be a list. Value will be a list consisting of EAT and then TEA and then ATE, and the next word will be EAT. After EAT, TEA. Okay, tan. So this will be ANT. ANT will be the sorted order of this one, and then this would point to the list of TAN and then NAT. Okay, and the order doesn't matter. So, and then another thing is bat. So for bat, it is ABT is the sorted order. ABT will be pointing to BAT. That's it. So this would be the grouped anagrams hash map. So I'm arranging that way. So how I'm doing that? For each string in the strings array, I'm grouped anagrams dot compute if absent. Grouped anagrams compute if absent. Sort string of str. So key will be the output of this method, sort string. So I'm passing a string there and I'm converting the string to char array, and then I'm just doing arrays.sort and then I'm converting it back to the string. So that gives the sorted version of the string. Like if I pass eat into this sort string, that would return AET, which is in the sorted order. And if I pass TEA, that would return AET as well. So if the value already exists for that particular key for that sorted string, then I'm not doing anything. If the value doesn't exist, then I'm creating a new array list as the value for that one, and then I'm adding the current string into that list, and then I'm returning the new array list of grouped anagram, only values. I don't care about this sorted string. I just care about these grouped anagrams. So these values only, list of values only I'm passing. This is the output that I need as I see here. Okay, let's execute it and then let's submit it and see it works. So if we need this one, just to verify this one, we can see how it is organized in that map. Grouped anagrams. Okay, we can see here, like as I saw, AET has eat, tea and 8. So AET has eat, tea and 8. And then here ABT has bat. So ABT has bat. And then ANT has TAN and NAT. ANT has TAN and NAT. So these three. So it's the same thing. So we can just remove that. I just printed it to ensure that it is more understandable or more readable. Okay, I just removed it and then submitted once again. Let's move on to the next problem. Subarray sum equal to k. Subarray sum equals k. So here, LeetCode 560 subarray sum equals k. Given an array of integers nums and an integer k. Okay, an array is given and a value of k is given. Return the total number of subarrays whose sum equal to k. A subarray is a contiguous non-empty sequence of elements within an array. Okay, continuous non-empty sequence. Okay, I think I get confused with these terminologies. What is subarray and what is consecutive subsequence and all those things. So here I would rely on these things. A subarray is a contiguous non-empty sequence of elements. So it has to be continuous elements, not like discrete, like it has to exist in consecutive memory locations, okay, within an array. So here k is equal to 2. JK, return the total number of subarrays whose sum equal to k. So this 1 plus 1 would be equal to 2 and this 1 plus 1 would be equal to 2. So there are only two ways to add it to the target value 2. And then for this example 2, k is 3. How many ways we can make k is equal to 3? 1 plus 2, yes, that is 3. And then just this subarray which has 3, that is also 3. So there are two ways we can make sum to 3. So there are two ways. Here you can see O of n square approach, space is O of 1, and then there is O of n approach where space is O of n. So here using additional space for storing the past prefix sums in a map, past prefix sums. So yeah, so I think this is kind of like a routine approach here. So public subarray sum, and I'm trying to, okay, okay, I'm just trying to see the combination of each of those, like from 0, I is equal to 0 and j is equal to I. And from j is equal to I keep going here and keep incrementing. If any value adds up to k, if sum is equal to k, then I'll just increment the subarray sum count. Yeah, if not, for every 0, every combination of I'll see keep adding j and see if that makes up to k, makes up to the sum k. And using cumulative sum approach, this is okay, this uses additional space as well. Okay, let's leave this. Let's come to the prefix sum map. Okay, using an additional space for storing the past prefix sums in a map. So what we are doing here, so in this case all we need to do is we have a prefix sum map, and then we are initializing it with the value 0. So there is, like, we can assume that if any nums is given, okay, if the nums did not contain any value, there is a 0 sum prefix existing. Like if the array was empty, then also the sum would be, or the prefix sum would be 0. Like there is a single combination with which we can make a 0. So for 0 there is one combination exists. This means for making up the value 0, one combination exists. So if the k was 0, then we would have just returned 1. Okay, and then now we are going through each element in the nums array. Okay, in nums, and prefix sum would be added, like we are adding the num value to the prefix sum every time we are going through this one. Prefix sum plus or minus is equal to num, and prefix sum map dot contains, if the map contains prefix sum comma this one, prefix sum minus k. In this case, for example, let's iterate through this array. Let's keep this one as an example here. Okay, and then here we have prefix sum which is equal to 0, and then we have prefix sum map, which is shown like this. Initially we have added 0, 0 and 1 to start with, and then yeah, nothing else, result, and then we have result which is equal to 0. So these are the initialized map, and then we have the nums 1 2 3. So now 1, we are considering 1, num is equal to 1, prefix sum is equal to prefix sum plus 1, so that will be 1. Prefix sum map dot contains key prefix sum minus k. Does it contain prefix sum minus k? That is 1 minus 3, that is minus 2. If prefix sum map does not contain minus 2, so I do not add anything to the result, so that combination does not exist. So now I'll just add to the prefix sum map the current prefix sum, and then if it already existed, I'll increment it. Otherwise I'll just add it. So for the prefix sum map, for what's the current prefix sum, it is 1, and then I'm adding it as 1 here. Okay, so now moving on to the next num. Next num is 2. So here prefix sum would become 1 plus 2 is equal to 3. Now we are checking if prefix sum map contains 3 minus k. K is 3, 3 minus 3. Yes, it does. 3 minus 3 is 0. It contains 0. So result would become result plus prefix sum dot get prefix sum minus k. Prefix sum minus k is 0. Dot get means it will be 1. So result would be is equal to 0 plus 1, that is 1. And then prefix sum map dot put prefix sum, which is 3. I'll add a value to the 3 here. So 3 1. I added the prefix sum, and then it come to the next element, which is 3, and then prefix sum plus is equal to num. So 3 plus 3, that becomes 6, and then I'm checking if prefix sum map contains prefix sum minus k, that is 6 minus k, 6 minus 3. Prefix sum map contains 6 minus 3, 3. Yes, it contains the key 3. Then I'm adding the result with whatever the value for that key. So result plus is equal to 1. So result plus 1 is equal to result would become 2. And then I'm adding to the prefix sum the current prefix sum, which is 6, and then I'm incrementing it by its previous value, which was 0. Okay, and then okay, no more values in the array, so I'm just returning the result, which is 2. So that's the approach that we follow. Prefix sum, that we need to remember that we keep adding the prefix sum, and we will check if there was anything existing in the map for prefix sum minus k. So let's submit it. Yeah, this works. Let's move on to the next problem. Top k frequent elements. So top k frequent elements. Okay, top k frequent elements here. In this case, given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. So nums is given us. So now we can see 1 is repeated 3 times, 2 is repeated 2 times, and 3 is repeated only 1 time. So top k repeated elements or top k frequent element is 1 is the most frequent element and 2 is the next frequent element, top k. So top 2 frequent elements. So we will just return 1 and 2. And here top 1 frequent element, only 1 appears once. So we are just returning once. So in order to compute here, we need to first basically compute the frequency of each number that appears here. So in order to do that, we are creating a hash map which is num frequency map, and then we are adding the frequency. How we are doing it? We are iterating through this nums, and then we are putting it into the hash map. If the number already exists, then we will increment it by 1. If the number doesn't exist, we will just add the frequency as just 0 plus 1, which will be 1. So the first whenever we encounter the number first time, we will add 0 plus 1 as the value. If we encounter it later, then we will get the value and then increment it by 1. So that's how we will get the frequency. And then once we have the frequency stored in this hash map, what we are doing is we are creating a min heap or a min priority queue, and then we are defining the order, sorting order in the priority queue based on the frequency. If we see here in this one, in this priority queue in which is of type integer array, 0th element will be the number and first element will be the frequency. So we are sorting it based on the first element for each elements. We are sorting it based on the first index. So based on the frequency, whichever will be lower, that would come to the top in the min heap. So now another thing is we want to make sure that we store a maximum of k element in the min heap always. So that would make sure that our operations are O log k on the min heap always, and we are doing it n times. So the worst case complexity will be n log k. Let's see. So we are iterating through all the elements in that hash map based on the key set, and then I'm adding it to the min heap dot add new int, okay, key and the value which is frequency. I'm just adding those two. And then if the min heap size is greater than k, then I'm emitting from the min heap. I'm pulling it away from the min heap. Once I go through all the elements in the hash map, then I would be remained with only the top k frequent elements in this min heap. Because if there was anything greater than the value in the min heap, here I was checking if there was anything greater than value in the min heap, then I would have pulled it away. I would have added it and pulled it away. It was never greater than that. That's why we are remained with that value, because I'm polling the minimum value. Since it's a min heap, I was just polling the minimum value. Okay, so I'll be remained with the top k elements in the min heap. Okay, new int k. So I have the integer array, and then I have the index value, and then I'm just adding the top k frequent elements into the array, because the output should be in the form of integer array. So I'm just adding it to the integer array and returning the top k frequent elements. And you may not return the answer in any order, so we are not caring about the order, caring about ordering it in a specific manner. That should be good. Okay, so we are done with 7 problems. Here, longest substring without repeating characters. Let's see. Here, longest substring without repeating character. This is the third problem in the LeetCode, and it's the LeetCode medium. Given a string s, find the length of the longest substring. Substring is a contiguous non-empty sequence of characters within a string without duplicate characters. Okay, length of the longest substring without duplicate characters. Okay, ABC and then A came, so that has a duplicate character ABC, so that is 3, and then BCA, that is also 3, CAB, that is also 3, ABC again 3, BC, B cannot be included. Okay, so the answer is ABC with the length of 3. So we are just returning the output length, which is 3. So we can do this using the sliding window. So let's see the current window. Like I maintain the current window in a set of characters, and then I have the start index as 0, and then I have the max length. I'm maintaining the max length as 0 here. Okay, now for int I is equal to 0, I less than s dot length I plus plus. Okay, I'm checking here. While the current window dot contains s dot caret I, if the current window contains s dot caret I, current window dot remove s dot caret start. Okay, while the current window contains s dot caret I. Okay, so I'm going through this I, and I'm just assuming that the window already contains something, but in our case window doesn't contain anything. Current window does not contain anything. So basically I'll just add the character to the current window, and then max length is equal to max length or I minus start plus 1. I minus start, so it is 0 minus 0 plus 1, that will be 1. So, and then I'll come to the next character, which is B, and the same thing, B is not contained in the current window. I'll just move on, current window dot add I'll add b also, and max length will become 1 minus 0. 1 minus 0 is 1 plus 1, so 2. Max length will become 2. And I'll do the same thing. C is also not contained in the current window. I'll skip it here, and I'm adding C to the current window, and max length will become 2 minus 0, so that is 2 plus 1, 3. So max length will become 3. And then comes A. Now the actual logic here. So when the current window contains s dot caret I, then what I'll do is I need to increment the like window which defines the previous one as well. Like that window is still at start. So I need to make sure that I find the duplicate value which satisfied this condition, s dot caret I. Like this could be B or C or A. Now in this case it is A. So until I remove A, this condition will be satisfied. So I'll just remove current window dot remove s dot caret start. So I removed A only in the first iteration only, and then I incremented start plus plus. Okay, now I come here. S dot caret I is not contained. Current window contains s dot caret I. No, it does not contain s dot caret I. Now I'll add A to the current window, this A. So now it is BCA in the current window, and then max length will be again 3 because I is now 3, but my start is 1. So 3 minus 1, 2, 2 plus 1, 3. So it will remain as 3. And then now I come here and B. So B will be the next letter, and the same thing will happen until I remove B. I'll keep incrementing the start. So I removed B, and my start is pointing to C here. CAB will be my window as of now. And then again I'll come to C. I need to remove C, and then ABC will be my window again. And then I come to B here, and then I will remove A also. I'll remove B also. Only CB will be my window, and then I'll try to add another B. So yeah, so that's how I'll return max length, which is equal to 3. So I'll just shrink the window as and when I find the duplicate, and then I'll expand the window if there are no duplicates in my current window set. So yeah, that's why I took the set so it's easier to check the contents using O of 1. So let's execute it. Using the set, it's easier to check if the character is contained in the set in the O of 1 with O of 1 complexity. Okay, we are done with 8 problems now. Let's take a break. Let's end the session for today, and I'll meet you people tomorrow. Please post me if you have any questions about this one, or if you are stuck with any preparation and need a solid plan in order to prepare for any interviews. And until then, I'll see you. Take care. Bye.